Hello explorers, it's that time again. It's Advent of Code, finally! And as normal, you can join the channel as a Christmas explorer and see all the uncut content before I publish any video. Day 4, Scratch Cards. The gondola takes you up strangely through the ground, doesn't seem to be coming with you. You're not climbing a mountain as the circle of Snow Island recedes below you. An entire new landmass suddenly appears above you. The gondola carries you to the surface of the new island and lurches into a station. As you exit the gondola, the first thing you notice is that the air here is much warmer. That it was snow on Snow Island. It's almost quite humid. It's where the water source is. The next thing you notice is an elf sitting on the floor across the station in what seems to be a pile of colorful square cards. Oh, hello, the elf excitedly runs over to you. How may I be of service? You ask about the water sources. I'm not sure. I'm gonna operate the gondola. I just operate the gondola lift. That doesn't sound like something we have. Though this is the island after all. I bet the gardener would know. He's on a different island though. The small kind surrounded by water, not the floating kind. We usually need to come up with a better naming scheme. Tell you what, if you can help me with something quick, I'll let you borrow my boat and you can go visit the gardener. I got all these scratch cards as a gift, but I can't figure out what I've won. The elf leads you over to the pile of colorful cards. There you discover dozens of scratch cards, all with their opaque covering already scratched off. Picking one up, it looks like each card has two lists of numbers, separated by a vertical bar. A winning list of numbers and a list of numbers you have. You organize the information into a table, your puzzle input. As far as the elf has been able to figure out, you have to figure out which numbers you have appear in the list of winning numbers. The first, which makes the card worth 1 point each after doubles the point of that card. Okay, so if we take this here, so if we have one card that is correct, we get 1 point. If we have two, we get 2. If we have 3, we get 4 points, and so on. So we will double every time. So that should be easy enough. Let's go with this as a puzzle input. And I think actually I will create a card class. So let's create a new package here, day 4, and then we will create a new class card. I think that is what we want to do, and in here I want to create a public card string. Really hate that. Let's see. So, and I also copied the puzzle input into day 4, so we should be ready there. And here for each string line we will create a new card. So let's have a list of cards. Cards equal to new array list. Something is weird with the pop-ups here. Let's see, card, import class. There we go. And we will say cards, new card line. Like that. And that. So that should be fine. So now we have a bunch of cards, and then we will go through for each card cards, and then take val C, get points, and then we take val and print out the points. So this, we need to create a new method for points, and if we go back to this one here, we can take one of these lines just so we know what we need to parse, like that. So we need to have one winning numbers and one just the other numbers. So winning, take a list of integer, winning, new array list, like that, and int card number, like that. So if we want to parse this string, we can take string card number is the string split by just that, and then we can take, we just call this array as we did last time, and then array 0, replace card with nothing, trim it, and then we can take card number equals to integer parse int. So this is very similar to how we parsed it last time. So this should be something that we are familiar with. So let's say string array 2. So array 1 split with the type symbol. So here we can say that we have the winning cards. So for string C array 2, the first part split by space. So these are the winning numbers. So here we take the winning, add integer parse int C. So that's the winning numbers. And here we also need to points equal to 0. So here on the second array, we want to say if winning contains parse int C, then we want to add to points. So if points equal to 0, then points plus plus, else points times 2. And here we will return points. So if we now go back here and run this, what do we get? We get 0. So something is wrong. Something is wrong. So let's go in here and debug a bit. If C is blank, continue. Let's do that for both of them. Then we get 13. And that is the correct value for this. So let's go over and run the full test and see if that works as well. Again, we get 28,538. Let's put that in. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. This video series is sponsored, so for all your hosting needs, go to DigitalOcean. If you want to learn something new this Christmas, then you can go to Coursera, take any of those 7,000 courses over there, or follow along with the simple Java course that I provided as well. And if you want to give your kids something really great for Christmas this year, you can give them a one-on-one course with a Code Combat trainer in order to learn coding. All the links can be found in the video description. Let's go to part 2. Just as you're about to report your findings to the elf, one of you realized that the rules have actually been printed on the back of every card this whole time. There's no such thing as points. Instead, the scratch cards only causes you to win more scratch cards equal to the number of winning numbers you have. Causes you to win more scratch cards equal to the number of winning numbers you have. Specifically, if you win copies of the scratch card below the winning card equal to the number of matches. So if 10 cards were to have 5 matching numbers, you would win a copy of each card 11, 12, 13, 14 and 15. Copies of scratch cards are scored like normal scratch card and have the same card number as the card they copied. So if you win a copy of 10 cards and have 5 remaining numbers, it would be a win to copy the same cards that original card 1, cards 11th, and this process repeats until you have none of the copies because you win more cards. Will never make you copy a card past the end of the table. What? This time the example goes differently. Card 1 has 4 matching numbers, so you win 1 copy of each next 4 cards. Okay? 2, 3, 4 and 5. Your original card 2 has 2 matching numbers, so you win 1 copy of 3 and 4. Your copy of 2 also wins 1 copy each of 3 and 4. What? Your 4 instances of card 3, the original and 3 copies, have 2 matching numbers, so you win 4 copies of 4 and 5. Your 8 instances of card 4, the original 7 copies have 1 matching number, so you win 8 copies of card 5. Your 14 instances of card 5, the original 13 copies have no matching numbers, so you win no more cards. 1 instance of the card 6, the original one, has no matching numbers, so you win no more cards. Once all the originals and copies have been processed, you end up with 1 instance of card 1, 2 instances of card 2, 4 instances of card 3, 8 instances of card 4, 14 instances of card 5, and 1 instance of card 6. In total, the pile of scratch cards causes you to ultimately have 13 scratch cards. Process all the original copies of scratch card until you have no more scratch cards, have 1, including the original set of scratch cards. How many total scratch cards do you end up with? So if we win 4, then we win 4 copies of the 4 coming numbers, so the numbers after that. The card also need to figure out int copies. And there is always 1 copy. Public int get wins. Return wins. So we need to have wins here equal to 0, and for each of these winning, we just take wins plus plus. So there we know how many wins we have. We also need to public void add copy. Public get int get copy copies. Turn copies copies plus plus. So now we can add to a copy and get number of copies. So we run through these cards, and then we need to do a for loop of in the first card we get here is cards get that particular index. So here we need to take get copies and add to val, like that. So that's the number of copies that this have. And we can also take int copies. Because we need to use that. And I realized that this add copies actually need to be an int. This copies plus equals to copies. Like that. And then we also need to have wins. How many wins we have? Get wins. And then we need to for when we start on I, then I'm less than v plus wins, v plus plus, but it also needs to be, and v needs to be, let's see, v needs to be I plus wins, yeah, and v also needs to be smaller than the card size, because we can't go past the card size. What? V, like that. So we go from the index we have now until the index plus wins. And for each of these cards, get this v, add copies, the number of copies. And then we can do it again. And if we do that with our original text, like that, what do we get? We get 15. So that's not correct. We need to move it one. There we have 30. So now we take and add copies to the coming numbers. So let's see if it works with the full set of tests here, or if we get the wrong value. Oh, that was large. 9,425,161. So let's see if we get right there. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. So what did we do now? What we ended up here with was that we ran through all the cards and we figured out how many winning cards we had, or how many wins we had on this card. And we also stored how many copies of this card is available. There's always one copy that we start with, but we can add more copies. So here we get the wins and we add more copies and we get the number of copies back. So what we did then down here is that we get a card, we get the number of copies on this card, we get the number of wins on this card, we add the copies for this particular card, whatever it is, to the value that we will print later on. And then we have a for loop here that we go through the number of wins we have, amount of times, on the index plus 1, so the next card and the next card and the next card and the next card, until we get gone through all the wins, or until we are at the end of all the cards. And then we just take the number of copies they found up here and then add them to those cards, which means that we will accumulate more copies going forward. So the second part of this was not that complicated. You just have to think about it a bit, and if you prepare and create a class, then everything becomes much easier. So this was today's video. I hope that you found this really interesting and fun. I hope you liked this video. If you haven't subscribed yet, please do that. If you want to share your own code or have any comments or suggestions, leave them down in the comment section down below. And I really hope to see you in the next video.